Hello, students. I hope you are good, well, and fine. And today's class, we will learn about Introduction to Euclid's Geometry. So, the first thing comes to our mind is what is geometry and what is more in Euclid's geometry. So, let's begin. Before beginning, let me give you outlines for today's session. First, the introduction. We will cover introduction and then basic concepts in geometry, the definition defined by Euclid's, the points, lines, plane, and then Euclid's five postulate, and then important axioms Euclid's took, and then some important definitions which are very important if you see from the perspective of geometry, or to be specific, Euclid's geometry. Let's move. So, what is geometry? So, basically, uh, geometry is a branch of mathematics that concern with properties of space, such as distance. If someone says what is the distance between this, if a tree A is here and tree B is here, then the distance between from tree A to tree B will be covered in geometry. The shape, if a building is like of a shape of some triangle, okay, or you say uh, or size, okay, or and even the relative position of figures. So all these things will come under the geometry. So I hope the geometry meaning is clear. So in summary, the geometry is just nothing but a study of properties of space, such as distance, shape, size, and etc. Okay, now let's move to this term. What's different in Euclid's geometry? So in Euclidean geometry or Euclid's geometry, it is the study of shapes of both plane shape and solid shapes. So plane shapes and solid shapes, and the relationship between these shapes in terms of lines, points, surfaces, and all of these words that the line or point or surface, what are they? These all are defined by Euclid's. Okay, so you will see the definitions for them also. I hope the Euclidean geometry meaning is clear. So in Euclidean geometry, in summary, we can say the geometry which is based on some axioms which was introduced by Euclid. Okay, I hope this is clear. Now let's jump to next. So now the introduction to this, the as the name suggests, introduction to Euclid's geometry, the geometry introduced by the Euclid's axioms. Okay, and he is also the father of geometry. Okay, and if you break down this word geometry, geometry meaning it's come from geo plus metrion. Okay, in which geo means earth in Greek language. Geo means earth, and metron means measure or measurements. Okay, so it is basically earth and measurements. Okay, I hope this quite interesting fact is clear to you. Okay, so let's move now. So in Euclid's geometry, the basic things one have to keep in mind is what is point, what is a line, and what is a plane. So point is just nothing. It is just a position in space. Okay, position in space. So it point used to used to represent the position in space. Suppose this is our screen, and if I mark here a point, then this is some position. Or if you see the whole screen, this whole screen, I can say that I am pointing out to this specific part of the screen. So point is used to represent position in a space. Now point has no parts. Okay, it has no parts. No parts meaning it can be if you divide, it cannot be broken down into parts. Okay, because it has no parts. It has no length, it has no breadth, it has no depth. Okay, it is just point to represent a position. Okay, now what is line? So line is a two sorry line is one dimensional thing. What I mean by one dimensional thing is that uh, one dimensional, that line has only length, no width. Line has only length. So line has only length, so it has no width, so it is widthless. So it is widthless. Okay, it is widthless. It has no width. So if I mean by that is, here is a line, keep going to this, going forever and forever. Line never stops. I can't just keep drawing line because it doesn't stop. So I just put arrow to make sure that it is going to left, and for this it is going to right. It is not stopping. Okay, so it means if I am here, 1D means, or the line means that we can travel either this side or to this side, either right side or left side. We can't go up or down. So we are restricted to only one type of movement, here or here. Okay, so this is one dimensional meaning. Okay, now the next thing was plane. So what is plane? Plane has width as well as length. It is two-dimensional thing, 2D thing. Plane is 2D thing, two-dimensional. It has length, it has width. Okay, length and width. So, and plane are never just like the lines. Planes are not just restricted, it keeps going on forever. For example, the paper sheet. Okay, paper, A4 size paper is a part of plane. Okay, if I extend this paper sheet from every side, for example like this, it's keep going on, here it's keep going on. Or just imagine a big paper sheet that covers everywhere. As long as you see, the it covers the area, so it is a plane, so it never ends wherever you see. So it is 2D because if I am here, if a point here, or if I am standing here, I can go there, I can go backward, I can move to this side. Okay, so that's why it is 2D. I can go left and right, I can go up and down as well, but on line I can't go up and down, only left and right movements are there. Okay, if you okay, I hope it is clear to you. Or if you imagine that you are standing on a rope, this is a rope, and you are standing on this rope, then either way of walking is you can walk to your front or backward. So movement is backward or at front. Okay, you can't move up and down. Okay, so that's is a perfect example of 1D, or a line which is small in in seeing. Okay, okay, I hope this is clear. The plane, the line, or the point. Will move to next slide. Okay, so let's move. So now first see the axioms. What Euclid mean by axioms and postulates. You will see the word postulates later. So first here, axiom, meaning of axiom is just basic facts which are granted without proof. Okay, so these are just assumptions. These are just assumption in math, in all over mathematics, which are used to many things, to create many definitions. Okay, for uh, as you will see how this many axioms in Euclid's geometry will be used to prove many bigger things. Okay, so let's move on. So first the some let's see some Euclid's definitions. First, about the point. Point is that which has no part. Okay, and it is used to represent a position in space. Okay, I think it is clear. Line is breadth less length. Okay, uh, I hope this is also clear. It is 1D. Okay, the ends of line segments are points. Okay, let me I already told you uh, about a point. Say this is point on in a plane. Let name it A. There's another point B. If I join these 2 points, this is my line segment. Line segment, because line segment, as name suggests, segment means a small part. A small part. So it is a small line segment is a small part of a line. So we know line never stops. Okay, but line segment have both ends, but a line doesn't have any ends. Okay, so AB uh, is a line segment, and in mathematics we represent it as like this. AB is a line segment. If A and B is a line, then we represent it by 2 arrow, which shows that it keep going to right and it keep going to left. Okay, okay, now there's one thing also. There is a point and it starts from here and goes forever to this side, and this type of thing is called as ray. Here it's origin. Okay, so in ray, one end is there, only one end only. So what is the end? This origin is the end. Okay, I hope this is all clear. So ends of a line segments are points. So as we already discussed, so line segment is a part of a line. So a line is cut down into a small piece like this. This is a line segment, and this is some point A, and this is some point B. So it has 2 endpoints. So line segment has 2 endpoints. Okay, a straight line is that which has length only, which means 1D only, as you saw the example of man on a rope. Okay, he only travels either front or back. Okay, let's move. Now, a surface is that which has length and width. As I already told you, a plane plane is also a surface. So because it has both length and breadth. Okay, but it doesn't have any edges. Edges means it doesn't have any borders or end lines. Okay, it keep going. As long as you keep walking, it will keep extending. Okay, as for example, like in a line segment, if one is standing here, if he try to move front, then after this point he will uh, get down. Okay, but in a line, if he is walking on a line keeps get extending. So whatever the side he chooses to walk, whenever he walks, the line keeps extending. If he reached here, the line also reached there. If he is here, the line also extended. So line never stops. Same with the plane. If it is a plane, then a person is moving here. Now it goes here. The plane also extended itself here. So plane has no boundaries or no edges, as you whatever you wanna call them. Okay. And now the sixth point says that the edges of surface are line. Okay. Uh, let an example of a surface. Surface has length and width. So as you know, a square is a surface because it has length and width. Okay. So it is a surface according to this point. And as you know, the edges, what are the edges of this? Edges are this. So it has edges. Surface has edges, and these edges are, as you see, are lines. Okay, I hope this is clear. Okay, now plane, I already told you a plane is a surface. Okay, yes, a plane is a surface because it has length and width, is that which lies evenly with the straight line on itself. Okay, I hope this is all clear. It is written what I have already told you. Let's move on to next. So a straight line. So a straight line may be drawn from any one point to any other point. As you can see, I have a to make a line. I have a point A and I have a point B. If a straight line may be drawn from one point to any other point. So I have given 2 points. So I can easily draw like this. So this will represent my line. If I don't represent by arrow, it is now line segment because it has 2 end points. One is A and second is B. Okay. So the second point also says that a terminated line or a line segment can be produced infinitely. Okay. Or you can also say that if a line segment is given with ends P and Q, you can extend it to get your line. Okay. For example, this is given or this. Let's move on. Now there's a remark. If you see, as I already told you about the axioms are just assumption in mathematics, all over mathematics, but you will see the Euclid's 5 postulates. So the postulate meaning, Euclid specifically used the word postulate for the assumption where specific to geometry. Okay, whereas axioms are used throughout mathematics and are not specifically linked to geometry. Okay, so the main difference is their axioms are all over or throughout the mathematics, while postulates are specific to geometry used by Euclid. Okay, so now let's move to the third postulate of Euclid's. A circle can be drawn with any center of any radius. Okay, a circle can be drawn with any center and of any radius. If I have a point, I can produce a little. If I have a point, let's say this point A, and then I can generate a little whatever distance line segment I want, and then create a circle with that distance, and this distance will call its radius of circle, and this will be my center. This will be my center of the circle. Okay, so you can do whatever the radius you want and wherever the center you want. Okay, now all right angles are equal to one another. The fourth postulate says the what we mean by right angles. Right angle means the 90 degree. So any 90-degree angles you take, all are equals. Okay, I hope these four postulates are clear. Let's talk about the fifth postulate, which is most important among all of the uh, all of five postulates. So the fifth postulate says if a straight line falling on two straight lines, okay, so one straight line is falling onto the two straight lines. So let's say like this is happening. Okay, this red line is falling onto two green lines as in the statement. Okay, the interior angles on the same side. So let's first see what are the interior angles. Interior angles like these all are interior angles. Okay, so all are interior angles drawn by orange color. Okay, I hope this is clear. So the interior angles on the same side of it taken together less than two right angles. So if let make a pair of two interior angle of same side. So what sides we are referring? So this line, this red line breaking two parts. This left part, this whole part is left and this part is right. Okay, so if I take two angles from right side or two angles from left side, so let's say I'm going to take these two angles from left side. Both must be interior angle and from the same side. So these are from left side and both are interior angles. If their sum, let's name them x and y. So angles are x and y. If x plus y is less than, so as the statement says, the interior angle on the same side of it taken together meaning sum, adding, we are adding the two angles less than two right angles. Two right angles means 90 plus 90, which is equals to 180 degree. Okay, so 90 plus 90, which is 180 degree. So if this happens, the x plus y is less than 180 degree. If this happens, then if we produce two straight lines indefinitely, so if we produce, let's try to now what we are doing, we are producing, we know this x and this y, both sum add up to less than 180 degree. So if we extend these lines, okay, then these line will intersect at some point. Okay, this is your fifth postulate statement. So this, if we produce infinitely, meet on that side on which the sum of angle is less than two right angle. So on the left side we took the angles and their sum is less than 180, and to the same side if we extend the line, then these lines will intersect eventually. Okay, so this is your fifth postulate says. Let me give you an example so you can also understand. So let's say your interior angle is 60 and this is your 120, and this is your let's say this is your 100, and this is your 80. If you add these, this is 60 plus 80, which is 140. And if you add this side, the left side angles, and the right side angle sum is 140, and the left side angle is 220. So if you see, the right side angles are less than 180. So then if you increase the lines to the right side, or to extend these lines, then these lines will eventually intersect. Okay, I hope from this you will get clear understanding of the fifth postulate. So let's move to next. Now, the important axioms or the important assumption in Euclid's geometry. First, a line is a collection of infinite number of points. Okay, if you try to see, here is our line, and if you try to zoom, let's zoom this part and make it bigger, then these are just infinite points which are present closely enough that you cannot see their difference from one to another. So these is just small infinitely many. There are infinitely many number of points. Okay, so this is our first assumption. Okay, now let's move to second. Through a given point, suppose we are given a point, say O, we are given a point O, and infinite lines can be drawn. So from this point, I can draw infinitely many infinitely many lines as one asked for. So if someone says draw 100 lines from this point P, so you can easily draw like this. You can draw infinitely. So infinitely means whatever the number uh, someone says, you can draw easily without facing any difficulty. Okay, so this, I hope this second important axiom is also clear. Let's move to next. So the third axiom says, given two distinct points. Okay, the axiom says we have two distinct points, let's say A and B, A and B. There is one and only one line that contains both the points. Okay, if you try to make a line which is passing through these 2 points, can you imagine how many of them you can draw? Let's say this is, okay, let me draw it properly for you. So one line is this. Yes, can you think another way to join these 2 lines, these 2 points? Okay, so no, there is no other way you can think of to draw a line from these two, passing from these 2 points. If you try to, you will only get this line. This is the only possible line which passes through these A and B point. So is this third point says, given to any distinct point, there is only one and only one line that contains both the points. Here this point is to be emphasized that we are using two distinct points. If the points are same, or there is only single points, then we can, in the previous or the second axiom, we have seen that we can draw infinitely many lines from a single point. Okay, so I hope third and the second uh, axioms are clear. Now fourth axiom says, if P is a point outside a line, so we have a line here, this is a line L, name L, okay, a line L, then one and only one line can be drawn, and also the P is outside line. So line is here, we have another point P outside, P is outside Okay, and there's only one line that can be drawn through P. So drawn through P which is parallel to L. So if someone wants to draw a parallel line, so first we want to know what is parallel line. So parallel line means lines which never intersect each other. Okay, I hope this is clear. Uh, are these lines parallel? No, because they intersect here. Are these line parallel? No, because if you extend this part, you will see there will be a intersection. Okay, so such lines which never intersect each other are said to be parallel. Okay, so we have to draw a line which is parallel to M, that is a line which doesn't intersect L but passes through P. So these type or such type of line only goes passing through P is the number of such lines is only one. Only one line we can draw in a such manner. Now let's I hope the fourth axiom is all clear. Now let's move to the fifth axiom. Now fifth axiom says two distinct lines cannot have more than one point in common. Okay, so I have two lines and they cannot have more than one point in common. What it says is uh, here M line is given, line M now, and line L is given. Okay, there are two cases. Okay, two cases. What are those cases? One case is when line intersect each other. Intersect each other means they meet at a point. Here they meet at P. And the second case is they never meet. Okay, they never meet or they are parallel lines. So, okay. So, in this case, if they intersect, there will be only one point in common. If they do not intersect, there is no common point. Okay, I hope this is clear. The fifth point is also clear. So now let's move to next. Now the sixth postulate or the axiom says two lines which are both parallel. Okay, let's say L and M both are parallel, meaning they never intersect each other. Okay, I am again and again repeating the definition for the parallel lines. Okay, so that you can easily remember or recall. So two lines which are both parallel to the same line are parallel to each other. This means if I have a line L, okay, and I have another line M which is parallel to L, M is parallel to L. In mathematics, we write like this: L, let me use different color, L parallel to M or M parallel to L. Okay. And another thing, the third line N, the name is N, is also parallel to L. That is, one thing is given this, another thing is also given to us, which is N is also parallel to L, or we say L is parallel to N. then in this case we can easily say that M and N, the both line, these two lines are parallel to each other. Okay, so from this, if this point is given, if this is given, then we can conclude, then we can say that M and N both are parallel. Okay, I hope this is also clear. Okay, so now let's move to next. So now let's see some important definitions from the perspective of Euclid's geometry. So first is collinear points. So what are collinear points? Collinear points are those points, or are points said to be collinear if there is a line in which contains all of them. If you think of a Q, or prayer queue, if you think, or the standing line in which people uh, stand in columns or row, then they all are collinear. Okay, so this is an example of collinearity. So Q, okay, Q, okay. So I hope this is uh, you understand. Okay, so now in schools, if you think the morning prayer, all students stand one after another. Okay, so this is also an example of collinear. Okay, so collinear, collinear. Okay, so and if you think the one hand distance between them, then you can think of the both one hand distance usually take in schools. Okay, so both are, so now this is a example of collinear, as I have already told you. Okay, okay, now the Q, QUEUE, I think this is the correct. Okay, okay, so if you see from the math perspective, we have points, some points, let's say P here, P, Q, R, and so on. If there are more, then if I can somehow join these all points in single line, connecting single line, then I'll say that these all points are my collinear points. Let me give you an example of non-collinear points. Let's say P is here, Q is here, R is here. Now if you try to join all the points but using only single line, so you can't do. So if you join these 2 points, the Q will lie outside. If you join this, then the R will lie outside. If you join this, the P will lie outside. So not co-linear points. Okay, I hope this is clear. Let's move. Now concurrent lines. Concurrent line means if 3 or more lines are said to be concurrent if there is a point which lie on all of them. So concurrent means if we have, suppose we have 3 lines, say T, M, T and M, L. Suppose we have 4 lines, okay, and they, all the lines are intersecting only at a single point naming P, then this type of condition or such type of uh, intersection of the lines will called as concurrent lines. Okay, I hope this is clear. If for example, if two lines are given, say L and M, okay, then the third one goes like this, then not concurrent, because one point is this, another is this, another is this. There are many points of intersection. Okay, but we want only one point of intersection. Okay, I hope this is also clear to you. Now let's move to next definition. Now, intersecting line. So intersecting line is, I have already been talking about the intersection or the intersecting lines. So the meaning of intersecting line is wherever the two lines meet. So the meeting point is called as the intersection point or the point of intersection. For example, this, the line M, the line L is intersecting or cutting or meeting at point P. So this point P is known as point of intersection, or we also say it P is a common point which lie on line M and line L. Okay, I hope the intersecting line concept is also clear. So let's move to next definition. So next definition is parallel lines. I've already given you what are parallel lines. So two lines, say L and M, okay, are said to be parallel if they do not, please see this thing, they do not have a common point. They do not have a common point, or we can say they do not intersect. Okay, they do not intersect or have a common point. These set of lines we call parallel lines. Okay, I hope these all are clear. Now let's move to next. Before moving, let me give you an example or ask you whether it is a parallel or not. So if I say one line is here, another line is here, are these lines parallel? One can say no, one can say yes. So the actual answer is not parallel. Why they are not parallel? Because they are intersecting, but we cannot see the intersection. Why? Because it is not extended. Let me extend. If I am going to extend this line like this, because line never stops, they never stop extending. So I can extend this line here, this line here. If you see, this is your region of common point or the intersection point, intersection region. So we have a intersection or a common point. Then from the definition of parallel, they are not parallel, because parallel lines do not have common points. Let's move to next definition. Now the line segment, as I am again recalling the definitions for you so that you can recall or memorize without any difficulty. Okay, so line segment, as name suggests, line segment is a small part or a segment or a small part of a line. Segment meaning a small a small part. So a small part of what? Small part of a line. So a small part of a line, we call it as a line segment. So given 2 points A and B on a line L, so we have given a line L, connected part of the line with end points at A and B is called the line segment. If we cut a small part out from a line. Let's say we cut here, and this point we name is, this point is A, this point is B, and then this little part or the little segment of the line will be called as line a segment. As the name suggests, line segment, small part of a line. Let's move to next definition. So next definition is interior point of a line segment. So as we already know what is line segment is a small part of a line. So here is my line, this red part is my line segment. And if we are talking about interior point of a line segment, this means a point R is called an interior point of a line segment PQ. Let's say naming this end is P, this end is Q. Then if R lies between P and Q, but R is neither P nor Q. So if R is interior, this means R must be in between here. R can be here or here or here. So if this happens, then we can say R is interior point of a line segment PQ. I hope this is clear. What if R is here? What if R is here? R or P both are equal. Then R is, then if this happens, then R is not the interior, is not a interior point of a line segment. Okay, line segment PQ. I hope this is clear. So the main thing to remember here is the R must be in between P and Q, but not on P and on Q. Okay. P is here, Q is here, here, right? And P is here, Q is here. Then if R is here, then it is wrong. If R is here, this is also wrong. So this kind is interior point of a line segment. Now let's move to next definition. Okay, now congruency of line segment. So this word, the congruence meaning. So congruence meaning the same, or the, if you remember the congruence of triangles, you heard of in smaller classes, the congruency of triangles. Congruency of triangle means if you, let's say I have a 2 rupee coin and another 2 rupee coin. Then if I put, let's say this is coin number 1, this is coin number 2. If I put this coin 2 on top of coin 1, then the coin 1 will not be visible, only coin 2, because coin 2 will completely cover the first coin. Similarly, if I similar thing if I do with coin 2, that is, if I put coin 1 on top of coin 2, then coin 2 will disappear or will completely covered by coin 1. So both the coins cover each other, okay, completely. So this type of whenever these type of things happens, then we say coin 2, coin 1, coin 2 are congruent, and the symbol for congruency is this. Okay, I hope the concept of congruence is clear. Okay, when we cover one thing to other and other thing to the first thing, then this type of thing is called as congruence. Okay. So if let's take an example of not congruent. So if you see that 2 rupee coin is bigger than the 5 rupee coin, okay, if you try to put this 2 rupee coin on top of 5, the 2 will completely cover it. Yes, it is cover completely. But if you try to cover 2 rupee coin with 5 rupee coin, it won't cover. Don't cover. So we say that these coins are not congruent to each other. Not congruent. Okay, I hope from these two examples you are getting the concept of congruence. Okay, and now congruency of line segment, what it means. So similar concept or the similar things will apply here. If I have two line segments, say A, B and CD are congruent if trace copy of one can be superimposed on the other so as to cover it completely, and exactly in this case we write AB is congruent to CD. In other words, we can say two lines are congruent if their length is same. Okay, if two line segments are congruent, then if their length is same. For example, I have if you are seeing this blackboard, I am drawing from this block to this A B, and I have another line segment A C and D. So one line segment is this AB. Mathematically I will write this, so CD. So to show that it is a line segment, I draw endpoints also. So AB and CD are line segments. Okay, let me draw it by red. Okay, CD is red. Okay, now if I try to cover AB using CD, then it will cover like this. Yes, it will cover AB like this. Then we can easily see that CD covers AB completely. Yes, CD covers AB line segment completely. Yes. But what about does AB cover CD completely? Let's see. If we try to cover AB, if we try to cover CD by using AB, can it cover completely? No, because if we try to cover CD, let's put this AB line segment, then we will this A is here, then it will go till here. It only covers this part. Only covers this part. So from this we can easily say that this part and this part are still not covered. So AB line segment does not covers CD line segment completely. Okay, so AB not congruent to CD. I hope this is clear in case of not congruent. But if I take AB here and CD here, then if I try to cover AB by CD, then it will cover both. Then it will cover CD completely, and then similarly CD covers AB completely, because they are only this much long, of the same length. So we saw that if AB, if so we saw the length of AB, if length of AB equal to length of CD line segment, then AB is congruent to CD. Okay, so always remember this thing. If the two line segments are having same length, then we can easily say that they are congruent. Okay, I hope this is clear. So this was the last uh, words from this paragraph. So in other words, we can say that two lines are congruent if their length is same. Okay, I hope this is clear. Now let's move to next definition, the distance between 2 points. Now we talked about the in just previous slide that we have, if we have two line segments and their lengths are same, then the line segments are congruent. Now how we are going to find out their lengths? So there's a formula. Let me give you a formula. If we know 2 points, let's say A and B, and we know we can easily create a line segment here, and we have to find out the length for AB, and we know point here A and here point B. You will see a formula in coordinate geometry. In coordinate geometry, I'm just giving you a formula just to be sure that there is a formula for to find out distance between any 2 points. Okay. So if points here is x comma y and here is a comma b, then the length for AB is equals to under root of x minus a whole square plus y minus b whole square. Okay, or you can if you want to uh, memorize it easily, just write like this, put minus sign and here square and then plus, then make root. Simple. Okay, so this is our formula to find out a length for any line segment if 2 points are given to us. So the distance between the 2 points P and Q is the length of the line segment of PQ. Just this is just okay, what I have already told you. So let's move to next, and this is our okay. So this is about rays. So what are rays? Rays, as I have already told you, we talked about lines. Okay, no end points, no end points. Segments, as it is line. Now line segments. Line segment means a small part of a line. So A, B. We take small part of a line. So here, A, B. Okay. So A and B. Okay. Line segment here. So it has two end points. Okay. Now I have already given you the what is ray. So ray is which is having one end point and another uh, ray. Okay, another end is not there. It is extending till whenever we go, or whenever we follow it, it always keep increasing. Okay. Okay, so it is like you can think of like if you are here, if you try to walk this way, then you will find no end. No end. If you try to walk this way, you will find end here. So only one end in ray. Okay. So ray is directed line segment. So it is a line segment, but in a specific direction. So we are giving a direction to there. Okay. So whatever is here, so we are giving to there. So directed line segment is called a ray. Okay. So I hope this is clear, and denoted by just this, denoted by A, B and this. So we can easily understand that it is a ray. Okay. So starting point is A and there is no end point. In a ray, we called A as origin or starting point or even a initial point of a ray, where the ray starts to a specific direction. Okay. I hope all these uh, all these definitions are clear to you. Okay, now we are comes to the end of our lecture. So this will be our last definition for this theory class. So what are opposite rays? Rays we already just saw in the ninth point. So rays are just directed line segment, or starting from a point and going to a specific direction and keeps going on. And opposite rays are just, if I have a ray, let's say AB is a ray, and opposite ray is the directed line segment but in the opposite direction. So here the direction is in this way, so the opposite is this way. So if I draw a ray in this direction, then this will be my opposite ray. So AB is my ray and AC is my opposite ray. Opposite. Okay, opposite ray. So two ray A, B and AC are said to be opposite ray if they are collinear. One can put a definition in terms of collinearity, because if you see, they are collinear. Okay, and a point A is the only common point of two rays. Okay, I hope these all are clear. Okay, so I hope you enjoyed these all the definitions, and I hope that you got all the definitions right and correct. So thank you for your time, and we'll meet again soon. Thank you.